Hello everyone, this is lesson 7.5 plus 7.6 on trig ratios. The last video you watched, you learned the basics of trig ratios. So you learned the mnemonic SOHCAHTOA, which stands for sine. So this is just a review. So the sine of an angle, the ratio of the sine of an angle equals the opposite side over the hypotenuse. And then the cosine of an angle represents the adjacent over the hypotenuse. And then the tangent of an angle represents the ratio of the opposite to the adjacent side. And you also learn that the sine of one angle equals the cosine of the other angle because the opposite and the adjacent would be flipped, but the hypotenuse stays the same. Right, so today we're going to learn how to apply our trig ratios and how to use them to solve problems, and also how to plug in sine, cosine, and tangent ratios, or sine, cosine, and tangent into our calculator. So for these ones, we're going to have to decide which one we are going to use. So for this one, we're given the angle 32, and we have the opposite and the adjacent side. So that means we're going to use the tangent function. So we're going to say the tangent of 32, so set up your ratio, equals opposite would be 11, and the adjacent would be x, so 11 over x. All right, so here's how we're going to solve for x. Since x is in the denominator, we're going to cross multiply. So we're going to put the tangent of 32 over 1. Also remember that it's not tangent times 32, so 32 can't be separated from the tangent. You don't divide by 32 or anything. These are stuck together, right? So cross multiply. So we get x times the tangent of 32 equals 1 times 11. Right, so now it's x times this. And now if I plug the tangent of 32 in my calculator, I actually get a number. So tangent of 32 represents some number. So remember, if you have x times a number, to get x by itself, you would divide by that number. So we're going to divide the side by the tangent of 32, divide by the tangent of 32. Okay, so those cancel. And then over here, we're going to take our calculator and do 11 over the tangent of 32. So let's grab our calculators, and we'll type in, also one thing that you'll need to do is make sure that your mode is in degrees and not radians. So radians is like the pi version of degrees. So you know how a complete circle is 2 pi? 2 pi is equals to 360 degrees. We'll do a whole nother extension lesson on that. So we're going to go to mode. Mode is right beside the blue second button. And then here, if you scroll down a little bit, it should be on degrees. Mine is not, because it's highlighting radians. I'm going to arrow down, arrow over, and press enter to highlight degree. Okay, and then do second quit to get back to the home screen, and type in 11 divided by the tangent of 32. So here, if you didn't notice, here you've got sine, cosine, and tangent button, just like on some of your old calculators. And then enter, and then we'll do it to 2 decimal places, so 17.60. So x is equal to 17.60. And now let's say we wanted to find the hypotenuse. If we wanted to find the hypotenuse, then we would do Pythagorean theorem. So we do x squared plus 11 squared equals hypotenuse squared. Since x is 17.6, we would plug that in for x. All right, so here we've got the same thing. We're looking at the angle 61, and we have the opposite and the adjacent. So we're going to do tangent of 61 equals 22 over x. Okay, put tangent of over 1, cross multiply. X times tangent of 61 equals 22. Divide by the tangent of 61. This is kind of the same setup and problem solving method that the other one used. And then plug that in your calculator. So 22 over the tangent of 61. Now, just to reiterate that the number inside of, or the angle here should always be less than 90, because one of the acute angles of a right triangle always has to be less than 90. All right, press enter. So that'd be 12.19. All right, let's look at a different example. So here we've got the angle 56, and let's call the other one 1, 2, so this would be 3 and 4. So still we have opposite over adjacent. So tangent of 56 equals x over 13. Okay, so now when we cross multiply, we're still going to put this over 1. Cross multiply, we get 13 times the tangent of 56 equals x. So now here we don't have to divide by the tangent anymore, we just have to multiply it by 13. So if your opposite side is missing, then you just have to do one step. If your adjacent side is missing, then you'll have to do 2 steps for the tangent. So 13 times tangent of 56 equals 19.27. Also, remember that x is a length, okay? It's not a degree. I don't really know what the length here is. You could call it units. It's not units squared, it's just units. All right, and so here, we've got kind of the same setup. So we've got the 70. So we'll do tangent of 70 equals opposite is h, hypotenuse is 40, put tangent over 1 and cross multiply. So we get 40 times the tangent of 70 equals h. So the height here of this lamppost is, I guess we'll plug it in our calculator first. 40. Also, you don't have to put the multiplication sign. You could just put 40 tangent of 70 is 109. We'll call it 9. 109.90. And this would be inches. Also, let's take a moment to look at what's going on here. So if you look here, you've got a shadow of the lamppost. So it's asking you if you know the distance from the lamppost to the edge here, and you know the angle of elevation. Angle of elevation is the angle from the horizontal that you are going up at. So this would be the angle of elevation 70. Wants you to find the height. And so you can assume that would make a right triangle there if this is horizontal. So that's what's going on with that image. So you'll see plenty of pictures like that too. Okay, here. So this is a very special question. So I want to make sure you understand this. Use a special right triangle to find the tangent of a 60-degree angle. So let's go ahead and draw a special right triangle. Oh boy. Okay, let me redo this. This is horrible. Okay. Maybe I'll use a straight edge here. Okay, so there's our short leg, long leg, and hypotenuse. All right, that's much better. Here's a right angle. Side opposite the long leg would be the 60-degree angle. Okay, so here we're going to let x equal 1. So remember, it goes x for 60, 30, 60, 90, x square root 3, and 2x. So that means if our short leg is 1, and our long leg is going to be 1 times the square root of 3, and then the hypotenuse is going to be 2. Okay, so in order to prove this, we let x equal 1 because that's the easiest thing to work with. And if you let it be anything more than 1, when you set up a ratio, it's just going to cancel anyways. So maybe if you try 2, see if it'll also work. So we'll do the tangent of the 60-degree angle equals the opposite over the adjacent, so the square root of 3 over 1, which simplifies to the square root of 3. So the tangent of 60-degree angle is equal to the square root of 3. That's all it's asking you to find. You're not solving for x or anything. That's it. All right, what if we let x be 2? So this would be 2. This would be 2 square root 3. So this would be 2 square root 3 over 2, which still simplifies to the square root of 3. So no matter what you let x be, it's going to be the same, the square root of 3. Okay, and why is that important? We will learn about that more when we do the when we learn about the unit circle. Okay, we'll do a little unit on unit circle later. All right, let's move on to some sine and cosine functions. Actually, wait, we have one more to do. Find the perimeter of the triangle, round to the nearest tenth. Okay, so if I want to find the perimeter, I need to know this side and the hypotenuse. So one thing we could do is we can find the tangent. We could use the tangent. And then to get this side, and then we can use Pythagorean theorem to get the hypotenuse. So let's do the tangent of 31 equals 6 over x, opposite over adjacent, cross multiply. This is like one of the first two questions. X times the tangent of 31 equals 6. Divide by the tangent of 31. Plug it in your calculator. What was it? 6 over tangent of 31 is 9.99. We could just call it 10 because it's to round to the nearest tenth. So next, this is 10. Let's use Pythagorean theorem to get the hypotenuse. So it says 6 squared plus 10 squared equals x squared, or h squared. Take the square root of both sides. So the simple way of plugging this in my calculator would be just to do the square root of 36 plus 100, which is 11.7. Okay, and then you would add them all up. So 16 plus 11.7 gives us 27.7 units. So that would be the perimeter of that triangle using the tangent ratio. All right, so now we're going to do sine and cosine. So how do we tell which one we need to use? Well, for this question, we are going to, at the moment, we're going to not use the tangent first. We're going to use the sine or the cosine first. So since you are given the adjacent angle, you would use the cosine ratio, because cosine uses adjacent over hypotenuse. So we're going to set it up as the tangent of 48 equals 10 over a. Oh, I'm sorry, cosine of 48. Okay, put it over 1 and cross multiply, so then you end up getting a equals 10 over the cosine of 48. Okay, if I plug that in my calculator, we get 14.9. Okay, and after we do that, you could use Pythagorean theorem, but let's say you accidentally got the wrong answer for A. So if that happened, then you would be using the wrong answer to figure out what B is. So instead, to avoid that problem, you could just use the tangent to figure out B. So we'll do the tangent of 48 equals B over 10. Cross multiply, so you get 10 times the tangent of 48. It should be smaller than 14.9 since it's a leg. 10 times the tangent of 48 equals 11.1. All right, so we found all three sides of that triangle. All right, for the next one, you've got the opposite and the adjacent missing, but you do have the hypotenuse. So let's use sine to find S and cosine to find R. So the sine of 43 equals S over 26. And then the cosine of 43 equals r over 26. So then we are doing 26 times sine and then 26 times cosine. So 26 times the sine of 43 and then 26 times the cosine of 43. So you get 17.7 and 19.0. 17.7, 19.0. All right, so there are a couple more questions. I'm going to kind of try to hit them real quick. So for this one, you've got a right triangle, you've got 35. I'm just going to set up the problem, or maybe have you set it up. So think about what would you use, sine, cosine, or tangent, and what would the ratio look like? Okay, so take a minute to think about it. So we're going to be using, since we have opposite and hypotenuse, we're going to be using the sine of 35 equals 11 over x. Right, so you would cross multiply and divide by the sine of 35, get your answer. Okay, and then a quick thing on angle of elevation, angle of depression. The angle of elevation is the angle, so imagine you're this guy and you're looking up at this girl on the mountain. Okay, the angle of elevation is deformed from the horizontal to the angle in which you're looking up at. So it's this angle right here. So in order to figure out your angle of elevation, you would draw the horizontal and then look at the angle that you're looking up at. And then the angle of depression is the horizontal and the angle in which you're looking down at. Okay, so also you can consider, like you can draw the vertical, and then that would create a right triangle. Okay, draw the vertical, and then you've got a right triangle where the horizontal is your adjacent, the vertical is your opposite, and the line of sight is, this is your line of sight, is the hypotenuse. Okay, so I'm going to let you do, actually we'll set up this question. No, where'd my question go? It's down here, I think. Okay, so for example, here, if you're trying to find your line of sight, you've got this 21. This is your angle of depression, because this is the horizontal, and this is the angle that you're looking down at from the horizontal. You've got opposite and a hypotenuse, so you would do the sine of 21 equals 1200 over x. Okay, so I'll let you practice more on the angle of elevation depression in tomorrow's assignment. Okay, so that is all for today. Sorry about the longer lesson than usual, but we had a lot to cover in this lesson. Hope you guys have a great day.